Namaste, this is JVN Dr. Vishal Saxena, Associate Professor in Mathematics and Statistics, Jayoti Vidyapeeth, Women's University, Jaipur. Today I am going to share a session on variance. This variance is a part of the measure of dispersion, and variance is the square of the standard deviation. This session is a part of the course Biostatistics under the program of MSc NND first semester, MSc Biotechnology and MSc Microbiology, MSc FST first semester of the university. Today's session, variance is an important topic, important part of this subject biostatistics, and as all we know that this variance, which is concerned with the standard deviation, is related to the part of standard deviation and measure of dispersion. In simple words, the variance is known as the square of the standard deviation, and as all we know that standard deviation a very important part of measure of dispersion, and it is a good measure of dispersion. So just to study about variance, we have to study about standard deviation as well. This standard deviation is a good measure of dispersion, but having some drawbacks also. So in the today's session we are going to discuss about this topic, and when and how it can be applicable, and how can we solve the numerical questions for the variance. The standard deviation and the variance both can be determined for the three kind of frequency series, like individual series and the discrete frequency series and the grouped or the continuous frequency series. So in all the three data we can find the standard deviation and the variance by the different method and by the different formula, and we can find the variance by calculating the standard deviation from these. Today we are going to share some slides to explain this with the mathematical terminology, mathematical formulas, and with examples to that. So we are sharing some slides. Here the initially standard deviation formula is given that there are two formulas mentioned here, and the upper formula thus can be or is known as the standard deviation in terms of individual series, while the next formula is for the group frequency distribution. The standard deviation is denoted by sigma. It is denoted by sigma, while the variance is denoted by sigma square. So in the individual series, the standard deviation is given by sigma is equal to summation yi minus y bar whole square upon n. So that is given by yi minus y bar whole square upon n, and it can be further simplified to the form like summation of yi square upon n minus y bar square raised to the power half. That means it is under root. While for the group frequency distribution, the sigma is given by summation of fi into yi minus y bar whole square upon n, and raised to the power half. That means it is under root. Or we can further simplify to the form that is means under root or the square root of summation fi yi square upon n minus y bar square. So this is the formula for the standard deviation and written by sigma. And if we want to define this standard deviation, which is the under root of the variance and variance, which is our today's topic. So standard deviation can be defined as it is the positive square root of the arithmetic mean. It is a positive square root of the arithmetic mean of the deviations and the deviations of the values or the data taken from the mean. So and the deviations are in the square form. So it can also be defined. It can be defined as it is the standard deviation as the positive square root of the arithmetic mean of the squares of deviations, squares of the deviations of the data, and the deviations are taken from the mean value. So this is the formula of the standard deviation, and if we have to find the variance, then it is given by simply the square of the standard deviation. And here the formulas are given for the variance, and we have seen in the last slide the values, the formulas for the standard deviation, that means for sigma, and now here we are having the formula for the variance, variance for the individual series and variance for the group frequency distribution. So in both cases the sigma square is the notation for the variance, and it is defined as in the similar way as in the previous slide. Just in the previous slide we have given the formula for standard deviation, means sigma, and here we are giving the formula for the variance, that is sigma square. So formulas are same, and just we want to say that yi is representing here the data, while y bar just denotes the mean of or the arithmetic mean of the given data series. Small n and capital N both are representing the total number of data, and which is representing the total number of data, and is equal to summation of fi. It is equal to summation of fi. Now here in this example we have to find the variance and the standard deviation of the question. So a data series is given that 1, 3, 5, 5, 6, 7, 9 and 10. This data series in the form of like individual series, and we have to find the variance as well as the standard deviation. So as all we know that the variance formula or the standard deviation formula sigma, in the formula of variance means sigma square, there will be this is given by summation of yi minus y bar whole square, that is mentioned here. The variance sigma square is given by summation yi minus y bar whole square upon n. Yi means the data, y bar is the mean of data, and n is the total number of data. So it means how can we calculate this one? So first of all we have to find the mean value. Mean is given by summation of data, means summation of yi upon n. So 46 upon 8, that is 5.75 is the mean, and that is the mean value. Now we have to find the deviations of the data from the mean value. So that means yi minus y bar. So here we can see the deviations from the mean value are calculated, and like yi means 1 minus 5.75, 3 minus 5.75 and so on. So all deviations have obtained, and now we have to just take the square of the deviations. That means yi minus y bar square. So which is coming there like in this way, 22.563, 7.563 and then so on. So these are the values of the yi minus y bar whole square, means square of the deviations. And now we have to take its summation, the summation of yi minus y bar whole square, the summation of the yi minus y bar whole square, which is given by, just we have to add all these yi minus y bar whole square value like 22.563 plus 7.563 plus 0.563 plus 0.563 plus 0.063 plus 1.563 plus 10.563 plus 18.063, and then we are having the total number of data, means n is equal to 8. We are having n equal to 8, and then how can we find the variance? Variance is given by sigma square, and sigma square means summation of yi minus y bar whole square upon n. Sigma square is given by yi minus y bar whole square upon n, and yi minus y bar whole square in summation. So this is given by 61.504 upon 8, 61.504 upon 8, and that is 7.69. So that is the variance, and standard deviation is given by the under root of this 7.69, means that is 2.77. So that is the way, that is the formula for the, that is the value of the standard deviation. So in this way we have found the value of standard deviation and the variance value, and in the similar way, if we are given that the frequency distribution either in the ungrouped data form or in the group data form, then what is required to do? Just we have to use the same formula for the variance that is mentioned here, summation of yi minus y bar whole square upon n, but we have to use one more term, that is fi, and the formula will become summation of fi into yi minus y bar whole square upon n, capital N. So this formula becomes summation yi minus y bar whole square multiplied by fi. So summation, in the summation fi into yi minus y bar whole square upon capital N. So just by this formula, means we have to find the deviations, then we have to find the square of the deviations, and then we have to multiply the deviations, square of the deviations with their respective frequencies, and then just in the formula we have to put the value of the values of the just the required terms, like summation of fi into yi minus y bar whole square, and the capital N value. Capital N means summation of fi, and we will get the value of the variance. So in this way we can find the variance and the standard deviations value, and these are the variance and the standard deviations are the parts of the measure of dispersion. So variance and standard deviations are the parts of the measure of dispersion, and measure of this standard deviation is a good measure of dispersion, but having some drawbacks, and but having some advantages, like it is better than the mean deviation, because in the mean deviation we have used the absolute values term, and absolute value term will give always the positive values, therefore the negative values will not be counted, and here just we are having all the terms, so that is good for us to use this standard deviations, and standard deviation is independent from change of origin, but it is dependent on the change of scale. So students are advised to use to learn and study with the concept part of this topic, and take numerical questions to find variance as well as standard deviations, and just prepare objective questions and descriptive questions for the competitive examinations also. With this I am concluding my today's session. Thank you.